Good morning. Today we have to begin the important parts of Chapter 14. We're going to do 3 topics in Chapter 14, and then we are going to have to do a few topics on probability and a few on statistics, and then we will be done for the year. I'm trying to go as slow as I can, so we're probably going to be working way into June, but I don't believe we're going to have to go further than that. Let's hope, and please keep up with your work every day, and you should be okay. So today's lesson is on finding the area of a triangle. From what I understand, you did this in geometry, or you should have done it in geometry. I don't really know. I'm going to pretend that you've never seen it before. Now, one of the things they have on the top of this page, again, is review of SOHCAHTOA. Opposite to hypotenuse for sine, adjacent to hypotenuse for cosine, opposite to adjacent for tangent. What we need, though, for the area of a triangle is the sine. The area of a triangle comes from the formula that is 1/2 two sides with the sine of the angle that's included between them. So if I take a look at this picture, what they've given me is 2 sides, and we don't know the height. If you remember back in, all your years of school, the area, why is this not writing? Let's try it again. There we go. The area of a triangle was always equal to 1/2 base times height, or we would write base times height over 2, because you took half of it. So you don't have the height. So if we use trigonometry and we need to find the height, this is also the opposite side. Let's use an O. And here's the 90 degrees, which makes the 8 the hypotenuse. So I'm using the sine. So if I wanted the height, I would have to say the sine of 56 is equal to the height, the unknown side, over 8. Now, I can make this into a proportion because proportions are really great when you're solving something with a fraction. And 1 times height equals the height. And then in my calculator, I am going to type in 8 times the sine of 56. Now, the only time your calculator should be in radian mode is for graphing. Anything else, you have to be in degree mode. So let's take a look. If your calculator is anything like mine, yikes, it's taken me forever to find my calculator. If your calculator is anything like mine, it's going to always revert back to radian. So let's check the mode. Yep, there I am. I'm in radian, so I always have to do this. And you should too, because you could do beautiful work but be in the wrong mode, and your work is like 100% wrong, which would make you feel a little like, what the heck happened? But that is what it is. So if I now quit out of here and I type in 8 times the sine of 56 degrees, I get 6.632. How do they want me to round this? They don't. So you know what? I can't round this. So here's my height. My height, I'm actually going to type it now because that's too many numbers. My height is now equal to 6.32, I think it was. 6323. So I'm going to stop it there because after the 3 are 2 zeros. But I'm leaving this on my calculator. This is just like what I had told you before. We always, always, always leave the numbers on the calculator because now they want the area of the triangle. Now, if I go back to this formula, area is base times height divided by 2. But notice the height came from the sine. So if you're going to do the area now, which is your base of 12 and your height now of your 6.63230058. I'll just put the whole thing that the calculator had said. Get an answer to this. So let's do that. So now I'm just going to hit times by the 12, which was the base. There's my answer. Because now, according to the formula, I have to divide it by 2. So once I got the answer, I can hit divide by 2, and I get 39.79308. Now they say round to the nearest square inch, so that would be 40 square inches, because here's the 9, and I look at the 7, so that would be 40. So if I go back to what I was typing, I have divide by 2, order of operations would definitely make the multiplication first, and this would be about, actually let me use the correct symbol. Since I've rounded, and I've done this on the board, and you can actually find this on the insert on Word where you insert symbols. This squiggle equal sign means about. It means you've rounded, which we did, and we got 40 square inches. So the height comes from the sine because opposite to the hypotenuse. You have to have the angle that's included between the two sides that they give you in a problem. So instead of doing the sine by itself, you can just write the formula as there's the 1/2, there's the two sides of the triangle, and there's the sine of the included angle, because again, let me go back to my little pen. If I were to talk about this angle here, this angle is the angle opposite the height if you were to drop the height inside. And so the height comes from the sine of C opposite to the hypotenuse. So using this formula, though, it just makes your life so much faster. Which of the following represents the exact area? Now, when they say exact, you're going to have to use your special triangle. That's always a hint. They say the word exact, we're going back to one of our special triangles. Now, an equilateral triangle is a triangle that has all three sides equal. Wow, that's a really bad triangle. You know what I'm going to do? Let's go to shapes. And here's a triangle. All right, there we go. Equilateral triangle. Now, on this equilateral triangle, you have 3 equal sides, and that means all your angles are 60 degrees because equilateral triangles, the angles have to add up to 180. 180 divided by 3 is 60. So your angles are all 60 degrees. If I were to now talk about a height, a side of 10, what that means is this side is 10 and this bottom side is 10. Let me just move this. And this is 10. So now, if I were to be using this formula, 1/2 base, 1/2 the sides with the included angle, this would look like this formula. Well, this area would equal 1/2 of 10 times 10 times the sine of 60 degrees. Now, the sine of 60 degrees, again, this goes all the way back to that chart from the beginning of the year. And if I were to come over here and just draw myself that special triangle, which we can never forget, here's my 30, my 60, my 90, and then my 1, 2, rad 3, special triangle. The sine of 60 is opposite over hypotenuse. So the sine of 60 exact is rad 3 over 2. Now 10 times 10 we know is 100. And the 1/2. So now we say, okay, if we multiply, we can get 100 radical 3, because 10 is rational, radical 3 is irrational, and just like we said from chapter 1, you got to know your categories and you can't change it. And 2 times 2 on the bottom, again, this is that invisible 1, multiply all your bottoms from chapter 3 when we did fractions, this would be over 4. Now, 100 over 4, 4 goes into 100 25 times. So here's our answer, 25 rad 3. So that, I'm going slow. Now, some of you pick up on things and can go much faster, and you don't have to wait for me on the video. Feel free to move at your own pace, because that's what you should be doing. Okay, so now we have an isosceles triangle has legs of 12 inches and base angles that measure 32. Don't you feel like you're back in geometry? Let's draw that triangle. So here we go. Sometimes it's just so much easier for me to use the tools. My base angle is 32. And my sides are 12 each. It's isosceles. Now, there's a number of ways I can do this problem, because I would need the 2 sides. I would need the 3rd side if I use this 32. So since that's not going to help me, what I'm going to actually do is I am going to go back to geometry and say, well, the 3 angles of a triangle must equal 180. So according to that theorem, 180 degrees is equal to 32 plus 32 plus this unknown angle at the top, this vertex angle at the top. 32 and 32 is 64. So now I have 180 degrees is equal to 64 plus x. I'm going to subtract 64 from both sides. So now if I do that, and 180 minus 64 gives me 116 is equal to x. So here's my vertex angle all the way up here. It's 116. Now I know this isn't a perfect picture, but that's okay as long as we get the job done. So now I have my 2 sides, and I have my angle that's included in between my 2 sides. So here is my included angle. So now when I find the area of this problem, my area is going to equal, and 1, 2, and I'm going to have 12 times 12 times the sine of 116 degrees. So here I am plugged into the formula, and I tried to write it a lot neater. So this way, you know, if you look back, you can follow it. And if I'm good with my calculator, and you really should be by now, you guys should be great with your calculator. It turned off on me, so I'm just going to double check. All right, still in degree mode. Here's my calculator can handle this whole thing. 1/2, and then I have 12 times 12, so you can write it all the way out, or you can write 12 squared. I don't care which way you go. And then we have the sine of 116 degrees. So if my face was longer, this whole thing would have been straight across, but look, the whole thing is there. I hit enter, and I get to the nearest square inch 64.7, because this would be 7/1. So that's my answer, 64.7. So the area is 64.7. And actually, again, because I rounded, my area is about 64.7. And I drew my picture, and I had to pull on a little bit of my knowledge from geometry. But guys, the one thing you'll notice about the end of the year, we're just using formulas. We're just plugging into formulas. So if you always just have out your classwork when you do the quizzes at the end of the week, you know, also too, notice on your quizzes, I don't pull any punches. I only ask you exactly what I had to do for the lessons, for the classwork and the homework. All right, so here, exercise 4, we have this triangle where AC is 24, BC is 30, and the measure of angle C is 40. And now we want to determine the area to the nearest square centimeter. Now, some of you don't need me anymore, so feel free to turn off the video. But if you're still having some troubles, let's go through it. So the area is, and I have 1/2. And then that would be multiplied by 30 times 24, either order, it doesn't matter, times the sine of 40 degrees. As long as the angle is included between the two given sides, you are in business and everything is fine with that. What happened to my little line that I drew? Let's try it again. I don't know what happened to it. There we go. And so if I use my calculator and I start again, 1/2. Whoa. Went a little too fast for myself there. 1/2 times 30 times 24 times the sine of 40 and again to the nearest square centimeter I would be 231 square centimeters. So this now is about 231 square centimeters. Now, using your answer, determine the length of the altitude. So now, if I wanted the altitude of this triangle, this would then be, I can use anything. I can use the sine of 40 is opposite to the hypotenuse. I can use the cosine of 40 is 30 to the hypotenuse. Either one, but I'll use sine just to be consistent. So if I do that, the sine of 40 is equal to the altitude, the opposite side, so I'll just use opposite, over the hypotenuse, which is 24. So if this were written in like up and down fraction, actually let's do that, so then this way nobody gets confused. I'll put the 24 under here. And I will draw a little line. So this then would be multiplying diagonally. So if I were to use the calculator and have sine of 40 times 24, where's my calculator? There we go. Sine of 40 times 24, I get 15.46, and they say they want the height, determine the altitude. Excuse me. They don't tell me to round. They don't tell me to round, and guys, that's the key. If they don't tell you to round, this entire answer is what they want. They want this 15.42690.263. So let's give them what they want. There we go. And that was here. So yeah, I was going to move the whole equation down, but it doesn't look like the smart board is going to let me right now, and I don't want to have a problem. All right, let's look at number 5. Now they're going to give you a description. A garden plot is being designed in the shape of a parallelogram whose sides have lengths of 40 and 30 feet. So do I have a nice parallelogram? Let's see all my shapes. Yes, I do. All right, here's my parallelogram. And my sides are 40 and 30. So this is 40 feet, and this is 30 feet. Now, the acute angle of this parallelogram here is 45 degrees. So if we take everything we remember from geometry, the one thing you should remember is that in a parallelogram, opposite sides are parallel and congruent. So this one's also 40, and this guy over here is also 30. Okay, I'm fully labeled. Now, why was it so important to fully label? Well, if I'm going to find the area of this parallelogram, I need this diagonal. Oops, hit the wrong thing. I need this diagonal here because another theorem from geometry, two congruent triangles make a parallelogram. That's one of the, so one diagonal constructs two congruent triangles. So if I find the area of this triangle and I double it, I will have the area of the whole parallelogram. So they kind of want you to just think that through and try to put together all those old things. So if I now go to the area is equal to, and again, let me just have my B times C times the sine of angle A. I'll just write out the formula, and now I need my 1/2. So just writing the formula for us. So I find this, and it's going to go both here and here. So that's now going to give me 1/2 times 30 times 40 times the sine of 45 degrees. And we get, and they say the nearest square foot, so they're telling us we're going to be rounding. So if I use my calculator and I type in 1/2 30 times 40 times the sine of 45, I get 424.26, so I would round that because they said to the nearest, so I'm just going to round that right now to 424 square feet. But this is just the area of a triangle. So this guy here would be, actually, you know what? Let's go back to here for a second. Let's take this on my calculator. This was 2640687. And now this is here. For the area, but this is also here for the area. So what's the overall area? Now with this on my calculator, I'm just going to hit times by 2, and I get 848.5. So this is why it's so important to not clear out your calculator. So now the area of the parallelogram is equal to 2 times this 424.2640687, and that gives me 848.5281374. So what I have to now do is I have to round this to the nearest square foot. So that's going to make this guy, now we have to use the about, 849 square feet. So just be super, super careful when it comes to the way they want you to round, because you don't want to give me something that's 1/10 of a point off, because believe it or not, I can't take that. So do your absolute best on these problems. They're actually quite fun. It's a nice little formula. And, you know, tomorrow we're going to talk about the law of sines and then the law of cosines. So, and that's it. We're only going to do 3 topics. I'm going to give you the formula. The questions are going to be very straightforward. So good luck. And again, let me know if you have any troubles at all.